So let's look now at what happens when we connect some components in parallel and measure the voltage across them. Let's have our cell again. I'm going to turn that around again because I like it that way. I'm going to put some wires in, and I think what I'll do is I'll put two resistors in parallel first of all. So straighten that up there. Let's just take you off for a moment. And another branch here with another resistor. Wire. Wire. Oops. And wire. Right, lovely. Okay, let's grab our voltmeter then and measure some values. So, measuring the voltage across the cell first of all. That's still 9 volts, same as we had before. Now let's move these connections down to the first resistor. Ooh, 9 volts. Move them down to the second resistor. 9 volts. Now at first glance that can be a little bit confusing, but let's think about what's actually happening there. We'll put that on circuit view for a minute and we'll show the current. Now I've got this in electron view, so we're thinking about, I mean obviously they're huge and there's not very many of them, but let's imagine that we're looking at electrons going around this circuit. So they're leaving the cell, and they're leaving the cell with the energy that they've been given by the cell, and then they're getting to this junction here. Now look at what's happening at the junction. Some are going one way and some are going the other way. So across, down, fantastic. And then they're rejoining here. So each one of these charges has been given a certain amount of energy. And each charge will lose all of that energy by the time it gets round to this side. But any individual charge only passes through one of the resistors. So each charge that passes through this resistor will lose 9 joules for each unit of charge. And each charge that passes through this resistor will lose 9 joules for each unit of charge. In this circuit, there is no way that any single unit of charge can go through both resistors. And that's why when we're measuring the voltage across the components, they all have the same voltage across them. We could add any number of resistors in parallel, and we'd still end up with the same voltage across all of the parallel branches. Still 9 volts there, still 9 volts there, and 9 volts there, because each of the individual charges is losing the same amount of energy because it's only going through one of the resistors. Let's see if we can use this information that we've learnt in a question.